Hey guys, Mr. Backerberg here. In this video we're going to be looking at zeros of polynomial functions. So as we're looking at the zeros of a polynomial function, a zero is another name for an x-intercept. But a nice way to think about it, if we're finding the zeros of a function, then what we're doing is we're taking our function and we're setting it equal to 0. So if we're looking at the function f of x equals x cubed minus x squared minus 6x, we're finding the zeros, so we're going to take this function and we're going to set it equal to 0. And then we're going to apply all of our algebraic solving techniques that we've learned along the way. So what I'm noticing on the right hand side is that every single one of my terms has an x in it. So I'm going to take out a GCF of x. So I'll be left with x squared minus x minus 6. And now as I look at that quadratic inside of my parentheses, I can actually factor that out a little bit more. And I'm going to think about sum and product factoring. So I'm going to think about things that multiply to negative 6 but add up to negative 1. So it would be x minus 3 and x plus 2. Now what I'm going to do with this is, since my function is set equal to 0, I'm going to take all of my individual factors and set them equal to 0 and solve. So if I take that first factor and set it equal to 0, I get x equals 0. If I take the x minus 3 and set it equal to 0, I would have to add the 3 over to the other side, so I would get x equals positive 3. And if I take the x plus 2 and set that one equal to 0, I'll have to subtract the 2 over to the right hand side, so I'll get x equals negative 2. So I'm going to have x-intercepts, or zeros, at an x value of 0, at an x value of 3, and at an x value of negative 2. And I'm going to graph this out on my calculator just to confirm my answers. So I've got my function typed into my calculator. When I hit graph, I can see that my graph is touching the x-axis at negative 2, at 0, and at 3, just like we said it was going to. Now sometimes as you're factoring out a polynomial, you get a factor that repeats itself. And that leads us to this idea of the multiplicity of a zero. And the multiplicity just refers to the number of repetitions of a factor or of a zero. And two things can happen at a zero based on its multiplicity. If the multiplicity is odd, then our graph will cross through the x-axis at that 0. But if your multiplicity is even, then your graph will bounce off of the x-axis at that 0. Now, as we think about that last example that we went through, each factor of our polynomial only showed up one time. There were no repetitions. So 1 being an odd number meant that our graph crossed through the x-axis at all of those zeros. But if we look at another example, so let's look at the function f of x equals x cubed minus 6x squared plus 9x. I'm going to set my function equal to 0 because that's what we do when we're finding zeros. I'm going to look at the right-hand side, and I notice that I should be able to factor out an x from each of my terms. And that'll leave me with x squared minus 6x plus 9. Now I can factor out that quadratic inside of my parentheses. If I do sum and product factoring, I need to think about things that multiply to 9 but add up to negative 6. So I would get x minus 3 and x minus 3. Since I have a repeated factor, I've got x minus 3 showing up twice, I can actually write that as x times x minus 3 squared. So I've got a factor that's repeating itself an even number of times. And technically out in front I've got a factor that's repeating itself only one time. Now when I take these and set them equal to 0, I would get x equals 0 and I would also get x equals 3. But I would technically get x equals 3 twice because it's a repeated factor. At x equals 0, because we only got that answer one time, that would mean that our graph crosses through the x-axis at 0. But at my 0 of 3, because I got that an even number of times, my graph is going to bounce off the x-axis at 3. And I'm going to graph this out on my calculator just to confirm its behavior. So I've got my function typed into my calculator. When I hit graph, I can see that my graph is crossing through the x-axis at 0, but it's only bouncing off of the x-axis at 3. That's going to be it for this video. Thanks for watching.